now want to discuss the median of a continuous random variable capital X. We discussed what we call the mode, the mean, and the variance. Now I want to see how do we deal with the things to do with the median. The median will take us what we call a quartile, a percentile, and a decile of any continuous random variable, for example, capital X. So the median, from what we discussed, we are maintaining the definition that the median must divide the data given, that is from statistics, the data given into two equal parts or halves. Now this side, instead of dividing the data, it is going to be dividing the area under the graph, or it will divide the total probability into two equal halves, as we are going to see. So the median, we are defining it for the purposes of the continuous random variables. We are defining it as, so this is the value or number that divides the area under a graph into two equal parts or halves. Yeah, dividing it into two equal parts is as good as dividing it into two equal halves. Now, we agreed when we were starting that the total area under the graph must always be a 1. But why it equates to 1? It is because a continuous random variable is assumed to be continuous on a continuous domain that runs from negative infinity to positive infinity. And because the maximum probability must always be a 1, it implies that when you integrate from negative infinity to positive infinity, and you integrate in the PDF, that is, if you want to get now the probability of the entire PDF from positive infinity to negative infinity, the answer must always be a 1. Now I want to introduce in something very small, that if this time you have the median and you want to find the probability of the median, so when you integrate from negative infinity up to the median value, you will not get a 1 because the median must divide that total probability into two equal halves. So we shall expect the probability to be what? A half. Or even when you sketch, if you don't want to go integration, when you sketch, the median must be that value which is dividing the shape of the graph into two equal halves, where the probability of one part is equal to the probability of the other part, and all those parts will be equivalent to a half. So if our f of x is continuous on a continuous domain, so if f of x is continuous on a continuous domain, to mean that f of x is defined from negative infinity up to positive infinity. If f of x is defined from negative infinity up to positive infinity, then the value of x, which is going to divide this interval into two equal parts, is what we call the median. So since the median must divide this interval into two equal parts, it is presumed to be in the middle of negative infinity and the positive infinity. So if we let the median to be m, to be small m, it means that this initial expression, which was defined from negative infinity to positive infinity, will still stand. But because we have not completed the entire interval. When we integrate from here to here, it should be 1. Because this is dividing the interval into 2 equal halves, it means when you integrate from this to this, the answer should be 1 divided by 2. Because you have integrated the halfway of the entire interval also, so you may calculate the median. You may calculate the median using this approach. That is when you integrate from negative infinity up to m, and you integrate in the PDF with respect to x, you equate to a half. So if after integrating you get the value of m, then that m stands to be the median, if and only if that value of m lies in the range of the values of x in which the PDF is defined. Now, in some textbooks, because this median must divide this continuous domain into 2 equal parts, it means some other person may define this as when you integrate, we started by integrating from this to this, and the answer was a half. Now we can integrate from this m up to this, because when you compare m and this, m is smaller than this. But from m to this, it is halfway of the total answer, which was initially 1. So when you integrate from m up to positive infinity, and you integrate with f of x with respect to x, the answer should as well be a half. So you can pick 1 and you move with that, and then find the median, which is the small of m. Now sometimes, but not always, you might have a case where we have, of course we said we have the simple PDFs, but we also have the compound PDFs. Those are PDFs that have more than 1 interval, and the simple ones are the PDFs which have exactly 1 interval. So if we are dealing with a PDF that has exactly 1 interval, then we go straight to using either this or that to get the value of m, which m stands to be the median. Now, if there is a case where you have a compound function, we don't go direct to this, but of the intervals in which the PDF is defined, we must first inspect the interval that is going to contain the what? The mode. So we are making a note that for the compound PDFs, we first inspect the interval in which maximum is the 3/4. So if they want to get the lower quartile, even that lower quartile will definitely, if f of x is defined over a continuous domain from negative infinity to positive infinity, then your lower quartile Q1 will also be somewhere in between there. It will not be in the middle, but it's going to be somewhere from negative infinity up to 8. Now, if you want to get that value of Q1, it means when you integrate from negative infinity, when you integrate from negative infinity up to the lower quartile value, which is Q1, and you integrate in the PDF with respect to x, because the lower quartile is represented by a half, we expect the answer to be a quarter. Because the lower quartile is represented by 0.25, then we expect the answer after integrating here be a quarter. We would have worked it in the reverse, but we don't want to confuse people. So if it is the Q1, it is represented by a quarter, and the integral must give you that probability as a quarter. So when you equate this and you get the value of Q1, it must be a value within the range of values of x given in which the PDF is defined. So similarly, if the PDF is compound, so for compound PDFs, we first test the lower quartile. You first test the lower quartile interval, and that is going to be the interval such that when you integrate from negative infinity of that interval, positive infinity of that interval, the answer must be at least of the PDF small f of x with respect to x, the answer should be at least that probability, which is a quarter. So if it is an upper quartile Q3, now this one becomes 3/4. And if it is a compound PDF, if it is a simple PDF, you go direct and calculate. But if it is a compound, then you must first test the interval that contains the lower quartile, and it will be that interval whose integral from the lower limit to the upper limit of the PDF is at least a quarter. So under quartiles, we do not have only the lower quartile, but like I've said, there is what we call an upper quartile. So in Roman 2, there is what we call an upper quartile, and this is denoted by a Q3. So our upper quartile, the logic does not change. When you want the position of the lower quartile, you get a quarter. If you want the position of the upper quartile, we use 3/4. So our f of x will be defined in a continuous domain from negative infinity to positive infinity, but the upper quartile Q3 is going to be assumed to lie somewhere in between negative infinity and positive infinity, so it will definitely be there. Now, if we integrate from negative infinity up to the upper quartile, which is a Q3, but integrate the PDF with respect to x, our answer must be 3/4. However, if the PDF is not simple, if it is simple, you go direct, but where it is not simple, that is when it is a compound, then you first determine the upper quartile interval. So we are noting further that for compound PDFs, you first test for the upper approach. Then after finding it, if the question is calling for the interquartile range, then you will generate it from the upper quartile minus the lower quartile. So you have upper quartile is represented by P3, and the lower quartile is represented by a Q1. So the interquartile range, our interquartile range is going to be a Q3 minus a Q1, where Q3 is the upper quartile that you have found using this, and Q1 is the lower quartile which you will have found using this one. Then you substitute, but you cannot go direct and get this one. So for this, you find the upper quartile separately and the lower quartile separately. Then you substitute them in the formula of the interquartile range. Now, Roman 4, still under quartiles, they may ask us to find the semi-interquartile range. So if they want us to find the semi-interquartile range, then we get half of the interquartile range. The semi-interquartile range is half. Like here, the word semi divides the interquartile range into two equal parts. So the semi-interquartile range is half of the interquartile range, and therefore our semi-interquartile range is going to be half of Q3 minus Q1. Where Q3, you will have found it using this approach, and also Q1, you will have found it using this other approach. Now the logic may not end there. They may go ahead and instead of asking for the quartiles, they instead ask for the percentiles. So our percentiles, in this case, percentiles, they will instead divide the area under the graph into, like here, the word percent is the percentile comes from percent. So the percentiles divide the area under the graph into 100 equal parts. When they say that please find P40, it means you are going to equate to a 40 over 100. If they tell you to find the 88th percentile, it means you equate the integral to 80 over 100. So we are saying under subsection part B, capital part B, that if we want to find Roman 1, P40, our f of x will be defined over a continuous domain that runs from negative infinity to positive infinity, implying that our P40 is definitely at some point between negative infinity and positive infinity. This one must always be an x value in this range. So supposing P40 is there, if P40 is there, it now means that when you integrate from negative infinity up to P40 and you integrate in the PDF with respect to x, the answer must be a 40 over 100. but the logic does not change. So if it is P75, this one changes to P75, and this will be 75 over 100. If it is the P80, this changes to P80, and this one becomes 80 over 100. However, P80 or P40, having P40 is as good as having a 48 percentile. So they will either call it the 48th percentile, or they will tell you to calculate P40. They can either say the 70th percentile, or they will tell you to calculate P70, but the logic does not change. Just spread your knowledge. So if the PDF is simple, we go direct and find the P40 using this. And if the PDF is compound, for compound PDFs, obviously we shall first test for the 48th percentile interval, and that interval is going to be, it must give this integral such that when you integrate from its lower limit to its upper limit, and you integrate the PDF small f of x with respect to x, the final answer must be at least 40 over 100. If it was the 80th percentile, this answer for the compound PDF would have been at least 80 over 100. So I request you to use that same knowledge and derive for me some simple notes like these ones for when the PDF or when the percentile of which is required is in Roman 2. What if they wanted the 70th percentile? How shall we have found it for both the simple and also determination of the interval? Then Roman 3. What if they wanted the 90th? The bit 90 or the 90th percentile? How shall we have covered it? Now, lastly, about percentiles, they may not bring them in form of P40 or 48th percentile or 70th percentile or P75. They may say the range of the middle 60%. So if they want the range of the middle 60%, it means you must take the difference of some two values which you are supposed to find separately. So if the question calls for the range of the middle 60%, we assume if this is our random variable which is defined and this is its f of x axis, from here up to down there, it is always 100%. Now, if they are talking about the middle 60%, it means it is in between, in the middle of this 100%. So this is our middle 60%. Now, if we want the two values, we are supposed to begin from this side. So at this side, we have a 0%. Then at this side, when you exhaust the entire interval, it has 100%. So since this is the middle 60%, and from here up here it was initially 100, it means the gap from here to there, from here to there, it must be the same gap from here up to there. This is a bit technical. So from here to here, it is equal to from here to here, because this is the middle what? 60%. Now, because the middle percentage must be 100, it means if we take away this middle 60%, the remaining percentage gaps which are of equal size. Then each part is going to take so for the middle 60%, it now means that each part is going to take the remaining percentage is 40. It is going to take 40% over 2, which is the 20%. So from this 0 up here, that one will be the 20%. Then from here up there is also 20%. Now we must create the two values that we are supposed to use to get the what? The range. You realize that from statistics, the range implies the difference between the highest and the lowest. So our lowest value runs from here up here. The values which are bound in the middle, there is a value that runs from here up here because the middle is ending here, and some other value that runs from here up there. So from here up there it is 20%. From here to there it is also 20%. Now the value that corresponds to the minimum value of the range is going to be the value from here to here, and that is the P20, which is the 20th percentile. So our range of the middle 60% is going to have its minimum value when it is corresponding to P20. So to get P20 before this procedure, that if you want P20, you must integrate from negative infinity up to P20, integrate f of x dx, and equate to 20 over 100. The maximum value of that, its maximum value is going to correspond to the move from 0. Remember, when comparing this, we always take the negative infinity first, then the other. So the first one is from 0, where 0 represents negative infinity, up to the P20. The next one will be from 0 up here, and if you do that, from here to here, it is already a 20. Then and this one, so it is a 20 plus the 60, so that becomes a P80. Or if you want to get P80, you can just say 100 minus 20 and you get this one. So the maximum value of that range is going to be a P80. Then finally, you do conclude that the range of the middle 60% will be the difference after generating the minimum and the maximum separately. Then the range of the middle 60% will be P80 minus P20, and that will be the solution, where we saw how you get those pieces separately after looking at these ones in detail. So you will try and derive this similar content for when they want you to get the range of the middle 50% of the distribution. You show us how the piece that you are supposed to use to get the range of the middle 50%, so that if it is set in the continuous, you can calculate the P using this and then substitute your final answers in the ranges of the values which you have obtained using that analysis. Now we said the median helps us to go in the in-depth of the Now, if they are deciles, they must divide data, or they must divide the area under the graph. For this case, they are dividing our area under the graph into 10 equal parts. So if we want to find any decile, for example, this 7, which we are referring to as the 7th decile, then your f of x will be defined over a continuous domain that runs from negative infinity to positive infinity. So this D7 is going to be presumed to be somewhere in between negative infinity and positive infinity, supposing your D7 is there. So if D7 is there, it means when you integrate from negative infinity up to D7, because this is divided data into 10 equal parts, so when you integrate from negative infinity up to D7 and you integrate the PDF with respect to x, the answer should be, because this is divided data into 10 equal parts, you get this 7 divided by 10. So the answer should be 7 over 10. And if the PDF that you have is compound, then you will have first test. You will test for the 7th decile interval. So test for the 7th decile interval. That interval, when you integrate over it, it must always give you the result of the integral when it is at least 7 over 10. So if we integrate from negative infinity to positive infinity, and we are integrating the PDF with respect to x, where negative infinity represents the lower limit of the interval, which might contain the 7th decile, and positive infinity represents the upper limit of the interval, which might contain the 7th decile value. So if you integrate over that range, your final answer must be at least 7 over 10. So if it is simple, you go direct and calculate. But if it is compound, you have to first test for the 7th decile interval, and then after getting it, you go back and apply this, and then get the 7th decile, as we are going to see in the examples. Now you spread the knowledge, because the question may not target the 7th decile only. They may bring a question that goes for D4. So what if they wanted D4? How would we have derived the knowledge that we wanted to calculate that? So you use that and get similar content of this kind, and they have it in your notes. But if they wanted D9, you also generate that and have it. Now, we can now conclude and say, since the median divides data into 2 equal parts, we always equate to a half. If it is the median, we equate to a half. Percentiles, okay, quartiles divide data into 4 equal parts. So if it is the second quartile, Q2, that's the second quartile, then it will become 2 over 4, which is the same as what? A half. If it is a percentile, and it is the 50th percentile value, we say the percentile is divided data into 100 equal parts. So if it is P50, it means, we said if it is median, it is a half. If it is the second quarter of Q2, it becomes 2/4, it's the same as a half. If it is P50, it is the 50th percentile, it becomes 50/100, which is still a half. Now if it is the 50th decile, which is D5, it becomes a 5/10, which is a half. So generally, if they want you to calculate the median, okay, if they want you to calculate the 50th decile, it is as good as calculating the 50th percentile. It is as good as calculating the second quartile. It is as good as calculating the median, because the probabilities that you are going to be equating to, they are all halves. If it is median, we equate to a half. If it is second quartile, we equate to 2/4, which is the same as a half. If it is the 50th percentile, we equate to 50/100, which is a half. And if it is the 50th decile, we equate to 5/10, which is also a half. Now, in our next video, we are going to apply the content which we have gone through under that in the continuous random variables. That is, if you're given the PDF small f of x, when it is simple, and also when it is compound. So take time and understand every bit of what we have talked about, and also how we have